Good afternoon and welcome to this month's show. I'm Luke McCormack. During today's show, we will discuss best practices with machine learning and artificial intelligence strategies in the federal government. With me on today's show are Chris BRAZIER, Division Chief at Defense Threat Reduction Agency, Brian Drake, Director of Artificial Intelligence, Science and Technology Directorate, Defense Intelligence Agency, Carly Jackson, Chief Technology Officer, Director of Science and Technology, Naval Information Warfare Systems Command, Melissa Sutherland, Vice President of the Defense Military Intelligence Division at Booz Allen Hamilton, Nicholas SPEECE, Chief Federal Technologist at Snowflake, and Chad CISCO, General Manager, Government Business Unit, Data Robot. Well, this is a big subject, an important subject, and a very fast-moving subject. And there's everything from we've got to cleanse the data, set the table, make sure we're ready for all this technology to ingest all this capability and start to use it, to very interesting ways I've noticed that things are being procured through challenges and seed money, et cetera. Lots of different aspects to this very fast-moving technology. Let's start with you, Chris, over at DTRA, as they like to call it, DITRA. What's going on over there regarding artificial intelligence and machine learning these days?
Hey, good afternoon, Luke. Thanks for having me. So from our perspective, and our efforts have really been focused on building our capabilities that improve end users' ability to identify, track, disable disruptive people, processes, and technologies. So our progress in ML/AI is based upon a holistic vision of integrating our people, our problem domains, and those problem domains are counter threat networks, counter weapons of mass destruction, great power, competition, national security, and then of course our hardware, software technologies collectively. And finally, it's managing the machine learning model lifecycle. So if I break that apart a little bit from the people perspective, right? Our capabilities are developed by our multidisciplinary data science team that we've been redesigning for about 4 years. And over that time, what we've learned is that an ideal team needs to contain members with background in software engineering, information technology, statistics, and machine learning engineering. And it's also really important that the team has access to or contains subject matter experts with our mission-related experience or our problem set experience that we're looking at. In the problem domain category, right, we're looking at the problem, primary problem across our mission space is that there's more data, text-based data, than humans can find, retrieve, or assess to meet demands of the mission requirements. So our goal is really to find ways to assist users in locating the relevant data to apply to the mission set. We've needed to find ways to automate manual and repetitive workflows, to access the information that answers the mission questions, threat discovery, and target identification. In the technology bucket, as we look at our knowledge of how to apply ML/AI, it's really grown, and we quickly realized that our data science team needed a hardware, for example, GPUs, not CPUs, and software environments that will let them scale their solutions across our larger mission space. This complete data science environment is located on our development network enclaves and that reside across different classification levels. But the core data science environment infrastructure is key in letting the team accomplish a couple of things. One, it ensures both quick development of machine learning and AI capabilities while also addressing the strict security needs of our organization. And then we also are exploring and iterate on models using mission data to deliver our capabilities, execute true testing and experimentation to successfully produce machine learning models. The data science environment resides right on top of our big data technology stack, which allows us to produce tens of thousands of unique documents a day, running them through several machine learning models and then making them discoverable. And then the machine learning subdomain selected to address our problem domain is in the field of natural language processing. So there's challenges with natural language processing, especially involve really speech recognition, natural language understanding, and natural language generation.
Lot of capability, a lot of stuff going on, a lot of horsepower that's available now, and a lot of data that needs to be processed.
Yeah.
Thanks for that top line. Brian, how about over at DIA? You know, there's a lot of activity going on over there and in your world. Give us a top line.
So we've had AI projects running in the agency for several years. Right now we have a reservoir of about 69 separate projects that are running at different levels of sophistication. We have challenges in managing those and keeping track of what they're doing. So we have crafted a defense intelligence strategy for artificial intelligence, which looks 5 to 10 years out. And we're trying to define what that future environment looks like for us uniquely as the premier defense intelligence provider for the US government. So some of the things that we have discovered going through that process is that we estimate that by 2025, we'll be encountering 175 zettabytes of data in the public sphere. That doesn't count the classified networks. This is just in the public sphere.
Wow.
So a zettabyte.
You got to tell the audience what zettabyte is, right? I'm not sure everyone's got that one.
Yeah, no, many people don't. So a zettabyte is 36,000 years of high definition video. Just to give you an idea of the general size.
There you go.
So if we were to commit
Netflix movies.
It's a lot to watch. So if we were to commit the entire human capital of the United States to go through a zettabyte, we'd never get there. So we estimate that into that future environment, we're going to need automated capabilities in order to process that amount of data, just to discern whether or not it has value for the intelligence enterprise. And because of that, that means that we're going to have to be looking at our activities in a different way. We have traditionally been doing our business processes on high-side networks and providing highly classified documents to policymakers from Congress, the White House, the Pentagon, warfighters out forward. We will still have that mission, and there will always be secrets in the world. But what it appears, at least for us in the future, is that a lot of that work will be done on low-side networks, not so much on high-side networks. So our business processes are going to have to shift toward more secure, unclassified processing and extracting the key insights we really care about up into the high-side networks. So those are some of the things that we're focusing in on.
Interesting to have that hybrid of high side, low side, and sort of merge that together to process some of these unique challenges that you all certainly have over there. Carly, how about at NAV War, as they like to call it? What's going on over there in regards to the use of AI and ML these days?
So at the Naval Information Warfare Centers, which are really our engineering centers that work all the way from our basic and applied research to fielded systems, our mission is really two-part. We're focused on developing systems that either resolve or create uncertainty with data, with information across multiple domains. Sometimes we talk about this and that our domain space is from seabed to space. So very broad applicability and very focused on the information domain. We just took a 10-year look at our investments in machine learning and AI, and our approach has really been multi-pronged. We have been focused on building the machine learning and AI workforce deliberately for at least 10 years, and we're even looking back into some very early publications from our most basic and applied scientists even before that. But for about 10 years now, we've been investing in almost hundreds of different projects, making some key hires in areas that were just discussed. And then also, even more recently, having the credentials and the experience to be able to apply some of that learning to real world problem sets. And that's really where the Warfare Centers excel, in that we have expertise that spans, again, from basic science and engineering all the way to support of fielded systems. Another big part of our investment was not just on the expertise side, but also providing the infrastructure that could help the scientists mature their expertise and their products in this way. Of course, this includes access to high performance compute platforms, training data sets, and others, and able to allow them to advance their machine learning algorithms.
Really seems like a lot of this, sort of new emerging horsepower that's readily available, along with this, again, troves of data, and have really allowed these data scientists to come up with some super creative solutions that solve some very important missions, including yours. Melissa, how about over at Booz Allen Hamilton? I know you all are right smack in the middle of helping these agencies out. What are you seeing across the top line there as far as activity in the AI/ML space?
Yeah, thanks, Luke. You know, as a company early on, we recognized that this is an area of focus for our business. And in particular, it's just an enabler. It was exciting to hear Chris, Brian, and Carly talk about their challenges, because that's really, you know, at the heart of what we've been focused on in Booz Allen. And it's exciting, you know, even last week, Bloomberg came out and announced, you know, Booz Allen is one of the top defense sector AI ML contractors. And this was, you know, really a lead that was cemented by our win in the Joint Artificial Intelligence Center. But we started investing a couple of years ago, and I want to highlight a couple key areas that we focused on. One, Brian alluded to this, is the ability to scale and reuse algorithms and ML and AI capabilities, both internal to Booz Allen as a company, but also for our clients, because there are a lot of pilot efforts out there that have a lot of potential, but how do you capitalize on those, take advantage of the investment, and import those capabilities to solve other client challenges, rather than reinventing the wheel every time, you know, we solve a challenge or start a new workload. So we created a AI ML platform called Modzy, and this is Booz Allen's enterprise AI platform and really our model marketplace. This way we can deploy, run, and manage an unlimited number of our AI models in a private, secure platform. But we also did this in partnership with companies like Hypergiant, NVIDIA, Crowd AI, other niche AI ML providers that want to make those models available, both to the whole of government and commercial. So we've had a lot of success there, where we can quickly access and train models. And this is a platform that we now have licensed model out there, so that our clients can capitalize on the investments we've made in these models, but also host their own. Think about it as a library, an open marketplace that agencies can store their models. Another key area to recognize, and I think Chris really hit on this as he was describing what they're doing in DITRA, is capitalizing on modern software best practices, and recognizing that while a lot of clients want to realize the potential of ML and AI, you have to have the ability to go from pilot to scale these capabilities. And that's really taking best practices in agile modern software development to automate deployment and provisioning of that software, but also the data. So how do we use what we call ML ops or data ops to also introduce AI and ML to automate the infrastructure, so that we can quickly move data at scale? I mean, we're talking, you know, mass amounts of data, and Brian alluded to this. Most of our challenges we're solving are in the high terabytes of data, and there are still a lot of manual extract, transfer, and load processes, even for those that are using small scale AI and ML applications. How do we automate that so we can help government scale it and do more with it?
Right, and not spend all your calories on just getting to the point where you can actually start to, you know, use the models. I love the idea of sort of a GitHub, if you will, of AI models. That's pretty interesting. Nicholas, how about over at Snowflake? Why don't you just remind everyone what Snowflake is and how you fit into this ecosystem?
Yeah, thanks a lot, Luke. Good to see you this afternoon. I'd love coming towards the end of the lineup, because there's so much great material out there that I can kind of go on here. To go back to Melissa's point, you know, Snowflake is the first data platform, and we say it's a platform built for the cloud because we've really capitalized on the technology that the cloud was built on top of: object storage, elastic compute, to offer the ability to point hundreds or thousands or tens of thousands of compute resources at a single repository of storage, a single object store. The benefit of that is to our end users, it looks like a SQL ANSI standard database, but to our folks who are more advanced users, it is an absolutely endlessly scalable platform that looks and acts like a database, but with so many more capabilities. And we've been applying a lot of those capabilities to the AI ML space. We continue to refine the platform itself. We came to the game with the ability to put very structured data, which is kind of table stakes in the database world, but to pair that data up with semi-structured data like JSON, XML, Avro, Parquet, Orc, all those great semi-structured sort of hierarchical schemas. That data can live side by side in its native format inside of Snowflake. We can do joins across that data, which in the AI and ML field is extremely useful to build insight out of the volumes of data that Brian was talking about earlier. A lot of that data is going to come from automated platforms. And then the data scientists that are building these AI and ML models, they spend 80% of their time refining all the data that has to go into the model eventually. Snowflake has built a lot of technology into the platform to allow those transformations in data pipelines to be accomplished in Snowflake using ANSI SQL. So we simplify the process of building that data and refining it into something that can be consumed. And finally, Snowflake knows that we're not the end all be all for every technology stack out there. We've innovated a bit with some Python libraries to allow technology partners like open source Apache Spark or Databricks to be used. And of course, we integrate with great new partners like DataRobot to bring AI capabilities to Snowflake as well. So a whole ecosystem to bring the AI and ML into the fold, along with an underlying platform to build on top of.
Love the technology that you guys have introduced into this ecosystem. Always great to see, starting from a green field, taking all the sort of lessons learned and what the industry needs now, including, you know, reducing the calories of the highly trained and highly sophisticated data scientists so that they can just do the sort of God's work, if you will. Chad, how about over at DataRobot? Why don't you first tell us what DataRobot is as far as how that fits into the ecosystem, and then what are you guys up to?
Yeah, good afternoon, and thank you. Excuse me, DataRobot, founded in 2012, is an enterprise AI platform. And so our capability is on every step, once you have a data set until you create mission impact, DataRobot can automate or streamline the steps one does there. So that includes a platform for data preparation. It also includes an AI catalog and automated feature engineering. And then the next step, and what saves the most time for many of our customers, is building a number of machine learning models across all the commercially available libraries, as well as our own custom built models, and then allows the users automated capability to evaluate those models for a number of features, including trust and bias, as well as how the model will perform under different conditions. And then the last step, which Melissa brought up, which is ML operations. We also have a capability to not only monitor DataRobot models, but ingest models built in another or other platforms or capabilities. So as you put the models out there, you can see a leading edge of when is my data starting to drift, which means model performance will start to degrade. And then after that, we also just have some capability around monitoring models in production for mission impact and helping you understand what's the library of projects you have working on. So we try to automate each one of those steps, think about how our users will deploy machine learning models and make the process more streamlined. What we're working on is, our primary focus in the government has been to create mission impact. We're working really hard to find those places and tough problems that the government needs to solve and get models in production and AI deployed within months, rather than sometimes these projects take a very long time. And obviously to do that, we're trying to help our government customers leverage commercial technology, like Snowflake was mentioned earlier, and think about what's that ecosystem of technology that's already been built for the commercial sector, and often cases is in deployment with a number of commercially customers, and then bring that into the government to streamline the process, leapfrog many times development of new tools and capabilities inside the government. And then last, I'd say where we're seeing the most impact today of models in production, soldier health and readiness, for example, financial management, things like increasing the agility of finances and then reducing fraud. And then last, what we're really excited about now is some things like sensor fusion, integrating multiple different types of data, say it's video, images, text, and bringing that together to automate a lot of the tasks that analysts have to perform to bring insights to the warfighter more quickly.
I love that omni-channel sort of different types of data stitch in there. That's fascinating. Well, we're going to take a short break and we'll be right back. You're listening to the Federal Executive Forum on Federal News Network.